Hello everyone, welcome to the SQRT channel. In this video, we are going to talk about a problem that we got from JEE Main from 2022. In this problem, we have inverse tangent of x to the power of 3 plus inverse cotangent of x to the power of 3 equals to k times pi to the power of 3. We know that x belongs to real numbers and we need to find range of k. Before moving forward to talk about the solution, make sure that you pause the video to think about this problem, and we will see you in about 15 seconds. To talk about the solution, let's first start by understanding what we are going to face here. We have inverse tangent and inverse cotangent. Remember, for an inverse tangent of x, x can be between negative infinity and positive infinity. However, the range of the function is going to be between negative pi over 2 and pi over 2. For inverse cotangent, on the other hand, the range of the function is going to be between 0 and pi. With that, let's move on and talk about how we are going to solve this problem. We have inverse tangent of x to the power of 3 plus inverse cotangent of x to the power of 3. I'm going to write it in a way that we can use the identity that we have here. Remember, inverse tangent of x plus inverse cotangent of x equals to pi over 2. This is very important to remember. We are going to benefit from it. The way that we are going to simplify this problem is using the identity that you are seeing here. Power of 3 of a plus b equals to power of 3 of a plus power of 3 of b plus 3 times ab times a plus b. Let's see how we are going to solve the problem now. If you are not familiar with the identity that we are going to use, let's prove it and then we will continue the discussion. We are going to prove that inverse tangent of x plus inverse cotangent of x is pi over 2. To do that, we are going to start with saying that let's assume tangent of a equals to x. Then inverse tangent of x is going to be a. Now we know cotangent of pi over 2 minus a is tangent of a. If we take inverse cotangent from both sides, the left hand side is going to be pi over 2 minus a and the right hand side is going to be inverse cotangent of tangent of a. And remember, tangent of a is x, so it's going to be inverse cotangent of x. Now, if we replace what we had for a, which was inverse tangent of x, then we are going to have inverse tangent of x plus inverse cotangent of x equals to pi over 2. So that's something that we are going to use. Make sure that you memorize this identity for your test too. Now let's start by simplifying the problem. We are going to write power of 3 of inverse tangent of x plus power of 3 of inverse cotangent of x as power of 3 of inverse tangent of x plus inverse cotangent of x minus 3 times inverse tangent of x times inverse cotangent of x times sum of inverse tangent of x and inverse cotangent of x. Now we are going to replace inverse tangent of x plus inverse cotangent of x with pi over 2. If we do this, we are going to face the equation that you are seeing here. We are going to have pi over 2 to the power of 3 minus 3 times inverse tangent of x times inverse cotangent of x times pi over 2. Now let's start with using one additional simplification. Instead of having both inverse tangent of x and inverse cotangent of x, I'm going to convert everything to inverse tangent of x. To do this, I'm going to use the identity again. I'm going to replace inverse cotangent of x with pi over 2 minus inverse tangent of x, as you are seeing here. Now we are having an equation that has some constant values and inverse tangent of x. I'm going to use t for inverse tangent of x to make it a little bit more readable. Now I'm going to apply some more algebraic manipulations. Here we have pi over 2 to the power of 3 minus 3 times t times pi over 2 minus t times pi over 2. In the original problem, they said that the whole expression is k times pi cube. Now we need to find somehow the values that we can get for k. After the first round of simplification, we can write pi over 2 to the power of 3 as pi cube over 8. Then if we do some more simplifications for the rest of the expression, we will have minus t over 4 times pi squared times t plus 3 times pi over 2 times t squared. Now let's go back, replace t with inverse tangent of x and see what we can get here. Additionally, I try to convert the expression into an expression that can understand better. The expression has two terms. The first term is a positive term and it has a power of 2 of an expression. It also has the second term, which is also a positive number. Now we need to find the range of the value that you are seeing here. Obviously, the minimum possible value that it can get is when the expression that we have in the first term is 0. Then the whole expression is going to be pi cube over 32. On the other hand, if we use negative pi over 2 for inverse tangent of x, then the whole expression is going to be maximized. If we replace that and then if we simplify it, you are going to see that the whole expression is going to be less than or equal to 7 over 8 pi cube. Now remember, in the original problem we had the expression equals to k pi cube. So k here is going to be between 1 over 32 and 7 over 8, and that's our final answer. Thanks for watching the video. If you would like to see more puzzles, math involved activities, and problems from different math competitions and Olympiads, please subscribe to this channel. Also, if you want to see problems from math competitions that you have in your mind, please let me know in the comments below, and I hope to see you in the next video. This is the SQRT channel.